Okay, so the rest of the muscle actions. These are going to be sometimes a little hard for you guys to see in the video. I'm going to do my best, and remember, I will get to see you again. You can ask me to do them again in class. Okay, so rotation. Rotations are the next ones, and they're in these pictures. So I'm going to show you rotation a couple of different ways. You're going to have to feel it with your own body, and then Spidey's going to help us with rotation as well. So rotation is basically taking a bone or a set of bones like the vertebra and like rotating them around their own axis. So what we looked at before was this was flexion, right? And this was extension. This was hyperextension. But if I rotate here, sometimes also called lateral rotation when you're going out. Okay, so if you're going out, that's lateral rotation. Okay, lateral rotation. So let's talk about lateral versus medial rotation and some other places that you can rotate. This one's really hard to see, but you can feel it, and then Spidey will help us as well. So if I start from anatomical position, right, and I'm not doing anything with my forearm, I'm doing it at my shoulder, and I laterally rotate, what it's going to feel like is my shoulder blades are moving closer together as I twist. So let's look at what Spidey can do. Okay, so Spidey's got electrical tape that's red on the anterior surface of his arm, and we're going to try to get him in anatomical position, but he resists because he's a superhero. So he's in anatomical position, like the palms of his hands are facing forward. So he's got red electrical tape on the anterior surface and black electrical tape on the posterior surface. So what I'm going to do is I'm going to rotate laterally first, and what's going to happen is I'm going to end up seeing more of the black just by moving the shoulder. Okay, I was moving, sort of twisting, and I'm not moving the elbow. Whereas if I rotate medially, I'm going to start anteriorly, and then I'm going to twist so that the black is coming around to the front side. And he's able to do it better than a human would because he is not real. So what you're doing is you are taking your shoulder joint, right? And you're either twisting it backwards or out, and that's lateral rotation, or you're twisting it in, and that's medial rotation. So how would you do that? So with lateral rotation, in order to do that, you're going to pull the bone backwards. So usually the muscle that does that has its origin on the back surface of the trunk and its insertion out here, and then it yanks it or twists it back. So, and then if you do medial rotation, you're going to have a muscle that does that with its origin somewhere on the anterior surface and its insertion out here. So I know you guys all already know, even if you haven't studied yet, you know what the pectoralis major is. One of its actions, because it goes from here to here, is that it can do not lateral rotation, because it'd have to be on the back side, but it can do medial rotation. Okay, so the answer to that blank right there is you will all often find muscles responsible for medial rotation, like twisting in. So if you do medial rotation at your shoulder, you're going to end up feeling like you're getting a good stretch on your back, but you're not using those muscles. You're actually using these muscles to pull your bone in. So you will often find muscles responsible for medial rotation with an origin on the anterior surface of the trunk and an insertion onto the limb. Okay, other movements, pronation and supination. These are a little difficult for a lot of students to understand. These look kind of like they're doing the same thing that we did before, but it's really only moving the elbow joint. So here, I am not going to move the shoulder at all. I'm only going to move the elbow joint. Okay, so if I show you on my arm, it's taking the elbow and twisting just at the elbow. But it's hard for you to see from there. So supination and pronation, they look like they're wrist movements. Sometimes people want to think that they're shoulder movements, but they're really elbow movements. So if we start again in anatomical position, then what would happen is the radius and the ulna would be parallel to one another. The palm would be facing forward, and you would be able to see the red electrical tape. Now, that is supinated. And then if you pronate, you're going to take the elbow joint and you're going to twist so that you don't see the tape anymore, or it's facing a different way, without moving the shoulder joint. So pronate. So can you see my hand? So if you end up supinated, you can always remember it because you can drink soup, and you pronate and you po it out. Supinate, pronate, pronate. Okay, so supination is when your palms are forward and your radius and your ulnar are parallel. It is really a result of doing this. You just supinated. And when you pronate, your palms end up backwards. Your radius and the ulnar are crossing one another. It's a result of rotating the forearm medially. So I'll show you in this video too, because it's hard to get. So she's going to show you just general rotation of the neck, and then she'll show you pronation and supination. Pronation, yeah. Notice that she's not trying to imply that you're moving the shoulder. Pronation, supination. So that's those two. And we can do them in class too. We could practice them. Okay. Special movements at the ankle. Unfortunately, after you just learned the flexion and extension stuff, the ankle doesn't use the same terminology, which is pretty annoying. The ankle movements like this are actually both considered two different categories of flexion, which is just as annoying to you as it is to me. Okay, so dorsiflexion and plantar flexion. I don't even really like those pictures, but I can show you what they are. So if we look at our skeletal friend here, and we look at his feet, okay, let's see if we can get his feet. Okay, so this is the dorsal surface. If you flex toward the dorsal surface, it's dorsiflexion. If you flex toward the plantar surface, it's plantar flexion. Dorsiflexion, plantar flexion. So if you want to do it yourself, if you want to feel what dorsiflexion and plantar flexion looks like, so dorsiflexion would be flexing toward the dorsal surface. So right now, take your dorsal surface of your foot and bring it up towards your shin, and you'll feel a good stretch on the back side, but you're using the muscles on the front side. So the muscles responsible for dorsiflexion are actually located on the anterior surface. They're right here. The muscles responsible for plantar flexion. So do plantar flexion right now by standing on your toes. Okay. So the muscle that's doing that is located on the posterior side. So let me show you an animation that will show you plantar flexion. So again, plantar flexion, you're moving the plantar surface. And look at the picture or look at the animation and tell me where the origin and the insertion are. We'll do the same thing that we did before. Okay, so where is the origin? The one that stays relatively stationary upon contraction, and it is right here. And the insertion is actually all the way down here on the calcaneus. It like kind of tucks under the calcaneus. Okay, and then the other two ankle movements are these guys, eversion and inversion that you can see right here. So if you evert, start with your feet in anatomical position and then take the sole of your foot and turn it laterally. So turning it laterally, that's evert. And invert is take the sole of your foot and turn it medially. So it's really just kind of like the subtle ankle movement. You don't have as much movement in eversion and inversion as you did in dorsiflexion and plantar flexion, but they help you to sort of be stable on rough surfaces. Okay. So, and then these guys, elevation, depression, protraction, and retraction. So elevation and depression, you can see them really easily at the jaw, but you can also see them at the scapula. So elevation, I'll show you at the jaw, and then you can see them there as well. Elevation is kind of what it sounds like. If you take a bone and you move it up, that's elevation. Move it down, That's depression. That's elevation and depression of my mandible. Now, you can see, and you can feel it in yourself, elevation and depression of the scapula. When you like shrug, that's elevation, right? And you go, that's depression. Elevation, depression. And you won't be at all surprised that the muscles that were responsible for elevation are going to be on top, and the muscles responsible for depression are going to be on bottom. And then opposition. So opposition is the last one. And then we'll start practicing with the names that are actually in your lab book. And this does take a little while, and I will be able to show you guys these in class as well. This is usually a very active lecture that I do in class, and I'm standing on the desk and stuff, but here I am by myself. So opposition is as in opposable thumbs. If I can take my pollex, my thumb, and I can touch all of my other fingers, that is actually opposition. And you can see it right here. So opposition, right? Oh, I forgot protraction and retraction. I'll go back and get those. So opposition as in opposable thumbs. So you are doing opposition. Now the only other one that I want to, and protraction and retraction both happen at the mandible, and they happen at the scapula too, but it is damn near impossible to see it on somebody else. You have to kind of feel it. But protraction and retraction, if I take my maxilla and my mandible and I keep them, relatively parallel to one another like they are right now, and I move this bone anteriorly without really changing the angle, there's protraction, and I end up with an underbite. And if I take these bones and I move it back without changing the angle, I'll end up with an overbite. Protraction, retraction, protraction, retraction. Okay? And you can do those with your scapula as well, but you kind of have to feel them. Like when I protract my scapula, I'm like pulling on it, but you can't see it. I can feel it though. Okay. So, and then we will do naming skeletal muscles with some of the examples from your lab book in the next video.